Okay. The today's problem is the problem that we are going to solve today is best time to buy and sell stock. This is Leetcode Problem 121. This falls under easy category. You are also given the solution. You can have a look at it. I'm going to follow the solution given in Leetcode. Let's go through the problem description once. So you are given an array, and in each element is the stock price. So this is the stock price on day 1, this is the stock price on day 2, this is the stock price on day 3. So the elements represent the stock price on any particular day, and it was also given that you can only perform at most one transaction. One transaction is buy and sell. You cannot buy it and sell it on the same day, which means that the profit is zero. You can, I think, but you can, but it doesn't make sense to buy and sell it on same day, because the profit would be zero if you buy and sell it on the same day. And you can only buy and sell at most once. You need to find the maximum profit. It was also given that you cannot sell a stock before you buy one. It's obvious that if you do not have a stock, you cannot sell it. You need to have a stock. In order to have a stock, you need to buy it. So you can only sell a stock after you buy one. So let's see the example one. So you were given the stock prices on 6 days. They are in some random. First it's 7, and then it goes down to 1, and then it goes up, goes down, goes up, goes down. So the answer is you can gain the maximum profit if you buy the stock on day 2 and sell it on day 5. So if you buy it on day 1, day 2, the stock price at 1 rupee, let's say it's 1 rupee or dollar, 1 unit, and you sell the stock on day 5, which is 6 unit, the profit that you gain is 6 minus 1, 5. And on the second example, see here you cannot, if you buy the stock here, you need to find a price which is maximum, which is greater than 7, but you do not have a stock price after day 1 which is greater than 7. So if you buy on day 1, there is no way you are going to gain profit. And let's say example 2 is the same, but it's in decreasing order. So if the array is in decreasing order, if this stock price is going down, you buy it on any day, there is no way you are going to gain profit, because the days that come after any day, the prices, stock price of the days that come after any day is less than the price on the day that you bought. I mean that if you buy it on day 2, you are going to have to sell it on day 3 for the stock price on day 3, 4 and 5, but you cannot sell it at the stock price on day 1. So so if you are going to buy it on day 2, you are going to sell it on day 3, 4, 5, but the prices on day 3, 4, 5 are in decreasing order, so there is no way you are going to gain a profit if the array is in decreasing order. So the stock price, the max profit that you gain is 0. So let's see how are we going to solve this problem. So the stock price generally is represented something like this. So initially it starts at somewhere here, and then on day 2 it increases, day 3 it decreases, day 4 increases again, day 5 it decreases, increases, and then decreases. So if you this can be solved using greedy algorithm. If you solve maximum subarray problem, using a cadence algorithm or greedy approach, not cadence algorithm, maximum subarray problem. This is the same pattern, maximum subarray. So if you solve any of this problem or this problem, you can solve the other problem as well. These two fall under the same category. Not the same, but the logic is similar, greedy approach. So what we do is we are going to calculate the local maximum. What do I mean by local maximum is the maximum profit that you are going to get if you decide to sell the stock on that day. Local maximum. So the local maximum at day 2 is the profit that you gain if you sell the stock on day 2, and this has to be the maximum. I will come back later to how we are going to find out the maximum, local maximum, but the definition is that the local maximum and at any particular day is the maximum profit that you are going to get if you decide to sell the stock on that day. Now, in order to sell the stock on this day, you are going to have to buy the stock. Let's say that we are going to calculate the local maximum on day 4. So in order to sell the stock on day 4, to find the local maximum, you need to sell the stock on day 4. In order to sell the stock, you need to buy the stock either on day 1 or day 2 or day 3. So, but the local maximum, in order to find the local maximum, we need to local maximum refers to the maximum profit that you gain. So in order to get the maximum profit by selling, you need to buy the stock at lower price on either day 1 or day 2 or day 3. So if you look at this, the minimum price, stock price is at day 3. So if you buy the stock on day 3 and sell the stock on day 4, this difference is the local maximum on day 4. Let's say it's A4. Again, how are you going to find the, let's say I wanted to find the local maximum on day 6. So in order to, what is local maximum? The maximum profit that you gain if you decide to sell the stock on day 6. In order to sell the stock on day 6, you need to buy the stock either on day 1 or day 2 or day 3 or day 4 or day 5. So, but in order to get the maximum, you are going to have to buy the stock at minimum price. From day 1 to day 5, the minimum stock price is at day 3. So this difference is the local maximum at day 6. Similarly, you go on about finding the local maximum on day 1, day 2, day 3, day 4, day 5, day 6, day 7. On day 1, it's obviously 0 because you are going to you need to buy and sell it on the same day. There are no previous days. On day 1, on day 2, the minimum stock price before this day is at day 1. There is only one day. So day 2 minus day 1 is the local maximum at day 2. So on each particular day, as we iterate through the array, we are going to calculate the local maximums, and then we take the maximum of this local maximums. This would give us the global maximum, which is the answer. So this is the greedy approach. So if you did not solve this max sub-array problem, you can after solving this problem you can go ahead and solve this as well. So how are we how are we going to do it in single iteration? So as I iterate through the array, I am going to keep track of minimum stock price. So if I am on day 1, the minimum stock price is day 1 only. If I am day 2, which is the minimum of this, day 1 only. So day 3, day 4. So if I am on day 4, I take the minimum. If I am on day 3, what's the minimum of the minimum stock price till here is 1. So I am going to take the minimum of 3 and 1, which comes to 3. So here the minimum stock price will be updated to 3. Okay. I'll take an example. Okay, how do I solve this? So I will keep track of my min price, as well as I'll have to keep track of global max also. So I will maintain. So as I iterate through the array, let's say that the array is seven one five three six four. So the min is on day 1, the min is 7, and I need to calculate the local maximum on day 1, which is 7 minus 7 equal to 0. As well as I will have to update the global maximum, which is 0. On day 2, I will have to update my min. My previous min is 7. Now I update to 1. Now it's updated to 1. And what's my local maximum? It's 1 minus 1 equal to 0. What's my global maximum? It's still 0. Now look at day 3. My minimum stock price till here is still 1. Minimum of 5 and 1 is 1. So local maximum, how do I calculate the local maximum day 5? I need to sell the stock on day 5 and sell the stock on day 5, given that I buy the stock at a lower price. So my minimum stock price is day 1 and my minimum stock price is 1, and if I am going to sell the stock on this day, it's 5 minus 1 equal to 4 is the profit that I gain. What is the now I update my global maximum of 0 and 4, it's 4. Now let's go to day 4. What is the local maximum? My minimum stock price is still 1, and my local maximum is 3 minus 1 equal to 2. Global maximum is maximum 4 and 2, which is still 4. Now let's take on day 5. My minimum stock price is still 1. If I am going to sell the stock on day 6, given that I buy the stock on day 1, the local maximum, the profit that I gain, or the local maximum is 5, and the global maximum is maximum of 4 and 5, which is 5. And on the last day, if I am going to sell the stock on day 5, last day, the profit that I gain, maximum profit that I gain, would be 3, and the global maximum still remains 5. So this is how we are going to solve this problem. So I need min price to keep track of my minimum stock price. I will initialize it to infinity. Local maximum I will initialize it to 0, and response, which is also the global maximum. Okay, let me rename it as global max, initialize it to 0. For each price in prices for each on each particular day, I'll update my minimum price, which is the minimum price till now, and the price on that particular day, which is the whatever, if the price on this particular day and minimum price till here, whatever is minimum will be updated, and I'll calculate my local maximum, which is the maximum of local max. So local, it's not max, it's the price minus minimum I think it should be max of price minus you are going to sell the stock on that day, and minimum price or 0. Yes, so if the price on any particular day, let's say that I think it can be just price minus minimum price. Yes, and my global max would be maximum of local max and global max till that price. So I'm just going to return a global max. Yes. So these two steps can also be combined. I can just combine it to one step. So let's run this code. Yes. Okay. See, if you are able to understand the algorithm logic behind solving this problem, you can go ahead and solve these problems as well. These are the same. This can be solved with same logic, but with some variants, with some tweaks, and also you can solve the maximum subarray problem as well. I hope you understood this problem. This is my first, I am making these videos. I am new to making these videos. This is very lengthy. This should not be this lengthy. I will try to improve and keep it as short as possible and make my explanation much clearer. Let me know if you have any comments, and thank you.